You are welcome to the GMAT 41's live class on organic chemistry. So in this class, I am going to teach you how to name organic compounds. But I'd like to say this before we kick off the class, that the system of naming compounds, known as IUPAC, the International Union of Pure and Applied Chemistry System of Naming for alkanes, alkenes, alkynes, alkanols, alkanones. They are already available on this channel, so it means you want to make sure you slide through the GMAT 41's playlists, Chem 102 playlists. GMAT 41's Chem 102 playlist on this channel. If you go to the home page, you have home, you have shorts, you have a playlist, live, Click on that playlist, and of course, you would see the lessons, okay, on Chem 102, where I treated the IUPAC nomenclatures of alkanes, alkynes, alkanols, alkanones. Being that this channel already has wonderful works on these other homologues, this particular live class is going to focus on alkanoic acid upward, all right? Alkanoic acid upward. So I encourage you to make sure that you make use of the GMAT 41's playlists. Very important, so you can learn the stuff that have been treated already. Okay. In our previous class, I remember, explaining the concept of functional groups. I remember telling you that for you to survive organic chemistry, you want to make sure you remember the functional groups. You want to know the functional groups of these compounds. Very important. And you'll be guided, because for any structure that I write on the board, the first thing you have to know is identifying the functional group. Identifying the functional group will help you to get to know what the homologue is. It's actually from there that the rest of the work would start from. Is that okay? It's from there that the rest of the work will kick off from. So very important. I want to believe that you've familiarized yourself with the functional group of these compounds. So we'll be moving on, like I said, with alkanoic acid. I'm trying to send messages to our groups to inform students that the class is kicked off. And if you're connected, you're welcome. That's good. Enjoy, you're welcome. All-in-one gaming, you're welcome. Mysterious maths, will you teach for Indian medical entrance needs? Yes, I will teach. All right, just send me a message. Send me a message, okay? And alongside the message, you can indicate the course outline. Are you following, right? You can indicate the course outline so that whatever I teach you guys will be within the framework of what your exam questions will be targeted towards. You can contact me on this number, right? This line. You can contact me on it and then give further details about the Indian NEET examination. Of course, I'll guide you guys through. So without wasting time, let's kick off. Like I said, we'll be starting with alkanoic acid. All right, IUPAC nomenclature of alkanoic acid. Alkanoic acid are also called carboxylic acid. They are also called what? Carboxylic acid. Garlic, Yemat Bay, you're welcome to the class. Okay, you're welcome. Emmanuel of 4, you're welcome. Good morning. All right. So, like I said, alkanoic acid, also called carboxylic acid. How do you identify alkanoic acid? Any compound given to you and you see this group, all right? This is the functional group of alkanoic acid. That's the functional group of alkanoic acid. You know that guy is an alkanoic acid. You can expand this. In our previous class, I already treated that. So I will not stress in the expansion anymore. Let me show you for this. This is how it is written. Are you following right? You can see it in that expanded form. So take notes. Like I said, I want to believe that you already followed up with our last organic chemistry class, because there I explain all these functional groups. If you're naming alkanoic acid, one thing you want to take note of is that the parent name must end with oic. The parent name must end with what? Oic. Very important for you to take note of that. Then other basic rules of naming organic compounds with, okay, where do you start your counting from? Where do you start your counting from? You know, identifying the attachments. Like I said, I've covered all of those already in previous homologues. Alkanes, alkenes, alkynes. So at the end of this class, you can check through the GMAETS 41 Chem 102 playlist. Are you following, right? To help to guide you with respect to certain things I'm going to be following, you know, some IUPAC nomenclature, IUPAC principles that I'm going to be following to give the name of the compounds that I've got for you guys in this particular live class. So without wasting time, I have this particular structure. Okay, let's just look at this one. Number one, we've got something like this: CH3, CH2, CH2, and then COOH. So I've got this. What is the IUPAC nomenclature of this compound? The first thing you want to take note of is the functional group. Very important. The functional group you have is this COOH, telling you that this compound is an alkanoic acid. It is an alkanoic acid. Take note of that. So that is the first thing. And there's one good thing about alkanoic acid. The functional group of alkanoic acid is a terminal functional group. Is a terminal functional group. I think I made reference to that under alkanal. Yeah, I made reference to that under alkanal. What do we mean by terminal functional group? Simply means that the functional group is always considered as number one. That carbon of the functional group is always considered as number what? One, wherever that guy is placed. Like in this case, COOH. Wherever you see, because sometimes it could have been written somewhere here, could have been written somewhere like this. That carbon bearing that OOH, we refer to this as the carbon of the functional group. That guy is always number one. So you want to take note of that. And that being the case, counting we start from there. This is 1, this is 2, this is 3, this is 4. So as simple as that. 4 carbon atom, the prefix is boot. The prefix is boot. And because this is an alkanoic acid, it goes with butanoic acid. Because all alkanoic acid with single bond between the carbon atoms are called anoic acid. Anoic acid. You mention the prefix and then you end with anoic acid. Butanoic acid. I'm saying this because we'll definitely meet a structure where you have double bond within the carbon skeleton. You won't call it anoic acid anymore. In that case, it will be enoic acid. To respect that double bond. Okay, so for this simple structure, the name is butanoic acid. Butanoic acid. Butanoic acid. That's the name. You say, I had to start with this so that you'll be refreshed. As we move on to other structures, let's look at number 2. What have I got for you here in this number 2? Now follow along as we've got this structure. This is the structure I have in number 2. So we have CH3. We have CH2, then I've got CH3, here COOH, I've got CH2, have CH2 here, then CH3. I hope this has not cut off from your view. I hope it has not cut off. Let me check up. Okay. CH3, good. It is within. It's within it. So that is the structure I've got, this second one. So quickly, you have to determine where or identify where your counting will start from. And like I told you, when you check all these, you will notice that the operating functional group is this COOH. Therefore, this carbon will always be carbon number 1. Let me indicate it. Number 1, carbon 1. From this carbon, you can now count from there and determine the longest chain. Determine the longest chain, whether it's straight or branched continuous chain. Whether straight or branched continuous chain. Now, with this as carbon number 1, you move this way because the next carbon linked to this is this guy. So this is carbon number 2. What if you decide to go directly up? This will be number 3. So you have only 3 carbons along that straight line moving on this way, upward. But clearly, from observation, you see that this is not the longest chain. So could we go 1, 2? This is number 2, however you are counting, because that's the carbon directly linked to this. Now from this carbon number 2, I can decide to go to the right, I can decide to go to the left to check which one contains more continuous carbon chain. Now, just for us to stress ourselves, let's go the left way and see how many carbons we have. But from my observation, clearly that left direction is not the longest. It's not. Okay, you can see these with your eyes, right? So 1, 2, 3, 4. So there are only 4 carbons along this direction. Now let us check here now, which of course is the longest direction. 1, 2, 3, 4, and 5. Good. So without wasting time counting, we go this way. It simply means that this becomes an attachment, a substituent, and this also becomes what? A substituent. Now, the name of this parent must end with anoic acid, right? Anoic acid, because we have this functional group COOH, which is oic, the alkanoic group. And then why is it that this will be anoic? A-N-O-I-C. Anoic, because if you check the direction of the longest carbon chain, you have single bond. So anoic, as in alkane for single bond, anoic. I'm saying this in case if we had double bond somewhere here, if we had double bond maybe between any 2 carbon, you can't pronounce it as anoic anymore. No problem. As we move on, hopefully we'll see a structure like that. So the name of this attachment is ethyl. This is ethyl. Ethyl, some persons pronounce it ethyl. The choice is yours. I think in the last class I told you the correct pronunciation of all these alkyl groups, because we call that alkyl, alkyl. The correct pronunciation is alcohol. Alcohol. So this is very ethyl, methyl. But anyway, that's not my business. I pronounce this methyl, meth for 1 carbon, eth for 2 carbons, then as an alkyl. So I've got E, and if you want to say I, the choice is yours. So how do we now name this? Following the alphabetization rule of approaching substituent. E comes before N. So I'm going to mention this E first. Ethyl. On the second carbon atom of the parent, second carbon atom, you have ethyl attachment, hyphen. On that same second carbon atom, you have methyl attachment, methyl attachment, and there is no other substituent, So you conclude with the parent name. The longest carbon of this alkanoic acid group is 5, and 5, the prefix is pent. The prefix is pent because this guy is an alkanoic acid. It will now be pentanoic. So pentanoic acid. Now, observe certain technicalities, some things we did here. You notice that between number and alphabet, we use hyphen. Then I want you to take note of this. Although the ethyl attachment and the methyl attachment are found on carbon number 2, they are on carbon number 2. However, for this structure, you are not allowed to write 2-ethyl methyl, 2-ethyl methyl pentanoic, with the idea of explaining that, okay, the ethyl and the methyl are both on carbon number 2. So just mention 2, and then 2-ethyl methyl is wrong. It's wrong. And you cannot even say 2, 2 ethyl methyl. Someone may be thinking that because 2 of them are on carbon number 2, you can repeat the 2 together, 2, 2, then ethyl methyl. You can't do that for this structure. It's not allowed. The reason is simple. The substituents, they are not the same group. This substituent you're saying, as in they are not the same. This is ethyl. This is methyl. Assuming that both of them are the same, let us assume that this one is methyl. This one is methyl. That is when you are now allowed to use 2, 2. Then because the groups are the same, methyl, for example, it's now going to be dimethyl. Are you following, right? But in this case, please, this is what you do. You must break up the 2s. Since the attachment, the substituents are different. 2-ethyl, 2-methyl, pentanoic acid. Don't forget the reason why I mentioned ethyl first. Because E, in alphabetical order, if I give you a dictionary to search out ethyl and methyl, you meet E before what? N. So you follow that order. Like I said, I've already discussed all these in previous classes under alkanes, alkane, alkyne, alkanols, alkanals, alkanones. So you can learn more about all these basic rules. So we are done with this particular structure. Hack Pro Server, I support you. You are doing very great job. Thank you very much. Thank you. Your channel should reach millions. Thank you very much for this wish. And I'm counting on you, dear friends. You are the ones to help me. Together with the support from our God and helper Jehovah, you friends out there are the ones I'm also counting on. As you share these, you encourage your friends about the academic wonders of this channel. I know very well that those who are determined to learn will reach out and subscribe to this channel. I'll be very grateful, and of course, hold a massive celebration today that the channel gets to 1 million as he proposed. Thank you very much for that wish. I also wish for that. Now let us move on to the next structure. Let's look at this third structure I have here under alkanoic acid. I'm going to write that here, number 3. I'm going to write that here. We've got this guy. I'll give you this before I move on to number 4. So we've got something like this. There is something I've been saying, in case you see an unsaturated bond between carbon atoms in, maybe say alkanoic acid or maybe any other homologue, you want to respect that double bond there. So how do we name this guy? It's simple, right? Counting, we start from here, 1, 2, 3, and 4. All right. So because we have the COOH, the alkanoic acid group, it overpowers this double bond in a way. However, if you are given the name of this parent, you must respect that within the carbon skeleton, you have a double bond somewhere. And remember, double bond, they are alkenes. The suffix, the ending part is "in." You must respect that when you are pronouncing this. Are you following, right? And then, because the name of the parent will end with "oic." Definitely because of this COOH. So let us see how we analyze this. We have 4 carbon atoms. The 4 carbon atom prefix is but. So I'm going to start with that. There is no substituent here, no attachment. No attachment. So we move on straight to the parent name, but. You must break that but there. You must break it because you need to respect that there is a double bond alkene there. Remember, if you are naming an alkene, the system of naming it is alk. You break it there, then put a number and in. That number will indicate the carbon atom bearing the double bond. Like in this case, after carbon number 2, you see the double bond. So this double bond in the system of naming will belong to that carbon number 2. So I'm going to break this as but 2. But 2. But 2. But I cannot say in like that. But 2 in, because this is not an alkene. This is an alkanoic acid. So that in now will bear oic. And therefore we have but2 enoic. Enoic. Going this way. Enoic. So instead of using a, anoic. In a case whereby all the carbon skeletons, you have single bond link in there. In this case, it's going to be enoic, respecting alkene functional group there. So that is what you do in this case. Good. Chiagozie Andrew, but2 enoic acid, that's good. However, the spelling of that enoic you wrote there, you wrote ENEOIC. That E before the OIC should not be there. All right, this is the correct thing. Enoic. You don't write the in fully. Is that okay? You don't write the in fully. Eziago Emmanuel, good morning. Glad to see you connect to the class. You're welcome. All right, let us move on. I've got this particular question now, which of course is going to be the last question under alkanoic acid. Then we move on to derivatives of alkanoic acid. No time. Are you following? And this particular question is extracted from UNIZIC examination, UNIZIC organic chemistry exam. So let us see what we've got there. I hope I can be able to squeeze the structure to this space. Let me view the camera coverage there. Gosh, I think it's going to be a bit difficult for that to enter. It's going to be difficult for that to enter. So let's see. Should I wipe somewhere from here? Should I wipe something from here? Please finish up with what you have there on the board. Finish up so that I'll wipe that part. We might not use the left-hand side much today. We might not use the left-hand side much today because, you know, the structure of a drawing or writing the structure, except perhaps I'll adjust. I might adjust the camera to capture. I adjust the camera to capture the left-hand side. And I can do that. Can do that. No problem. Can do that. So let me adjust. Manage up. All right. Manage up. Let me adjust it. And let me see this. The coverage once again. Good. So I can actually take off from here. It's possible. So this is the structure I have. Very interesting structure. Let's see what we've got. Number 4. Number 4. So I have CH3, COC. Now we've got this. This is Unizik exam question, Nnamdi Azikiwe University, Awka here in Nigeria. Right, so we've got this particular question. They've tested their students on it before. Let's see what we've got. Very interesting structure, like I said. So we've got this here. Some of you may not like what you are seeing on the board. Some of you may not like what you are seeing, but don't worry. You know, when I break it down, you will understand. It's 1 plus 1. It's 1 plus 1. So I'll see H3 in brackets here. Then we have CH2 and then CH3. So that's the structure. Now this structure for students preparing for O-level examinations and or maybe JAM, that's talking about WAEC, NECO, JAM, right? You have no business with this structure. You have no business with this structure. This structure is meant for those in advanced level. Yeah, but it does not matter. You can still, you know, learn something regarding this. You can still learn that. There is nothing wrong with it. Is that okay? There's nothing wrong with it. Besides, you are graduating into advanced level. So this is the structure we have. Now, there are certain things you want to take note in this structure. Because I can see, you know, different functional groups. I can see different functional groups here. This is a functional group COOH. You see this guy you are seeing here, this double bond of oxygen attached to this carbon is a functional group on its own. This thing you are seeing is alkanone functional group, that is ketone. Alkanone, ketone functional group. Then you have this functional group double bond for alkene. So it's much like we have 3 functional groups there. The carboxylic acid functional group, that's alkanoic acid. We have alkanone and we have alkene functional group. Now, what should the students know about these guys? When you have a mix-up, of functional group, a student should be able to determine the main functional group that will overpower the other ones. And there is one guideline I want to give to you. In our previous class, when I listed out the functional groups, the order I followed actually is the order of preference. The ones below overpower the one above. The ones below overpower the ones above. If you take your mind back, when I was listing these guys, you notice that COOH was below these other ones. Are you following? COOH. However, another good reason, another thing that will help you know that the COOH, alkanoic acid, will supersede in its strength as for helping you to know what the parent would be, is the fact that alkanoic acid functional group is a terminal functional group. Is a terminal functional group. But alkanone functional group is not a terminal functional group. It's not. In fact, try to take the lesson, all right, the video lesson on alkanone. IUPAC nomenclature of alkanones. You will hear where I talked about that. Whenever you see this functional group, it is never a terminal functional group. Therefore, in some cases, you can respect it as a functional group. In other cases, you can consider it as a substituent, as an attachment. When you consider it as a substituent, is a case where this guy is seen in a structure, where in that structure you have a terminal functional group. COOH is a terminal functional group, like I said. Look at this guy, alkanal. Alkanal is a terminal functional group also. Look at this guy, which is the next one we are going to see, Agabi. Second to the next one we are going to see, is a terminal functional group. Look at this guy, is a terminal functional group. This is a derivative of alkanoic acid. This is derivative of alkanoic acid. They are terminal functional group. Look at this one. This one for alkanoate is also terminal functional group. So whenever you see them, it's a derivative of alkanoic acid. Whenever you see them, you give preference to them as the parent. You give preference to them as what? The parent. These guys, they are all terminal functional groups. All right, let me wipe this. I think I listed them under the IUPAC nomenclature of alkanones. So like I said, your learning should not all be about live class, when I am on live. You can actually also go through the GMAETS 41's playlist on this channel. You have lots of academic wonders there to guide you, all right? So having explained this, the main operating functional group here will be this COOH. It supersedes this and this. It simply means we are going to take this O as an attachment, and that will be oxo. And then, of course, this double bond would be a sub-attachment within the parent name, just like you have it here. Therefore, counting, we start from here to determine the longest carbon chain. 1, 2, 3. When you are counting, look at this guy, this double bond. You notice the pattern in which double bond in alkanoic acid was being named here. The double bond does not exist as an independent substituent. It doesn't exist as an independent substituent. What do I mean by that? Like in the case where you could have something like, okay, 2-ethyl, 2-methyl, 5-hydroxyl, 4-oxo. You cannot handle alkene, double bond functional group in that way. You can't. Double bond functional group, if you see it as a mixed functional group in any other structure that has a terminal functional group, like in this case, the double bond appears as a substituent, a sub-functional group in the parent name. For that reason, if you are determining the longest carbon chain, if you want to know the longest carbon chain, it must, if you are counting, like in this case, carbon number 1 will start with this COOH. When you are counting, the longest chain must include that double bond. Must include that double bond. So 1, 2, 3. You see, I've included this double bond. Then if you go this way, 4 and 5. 1, 2, 3, 4, 5. So I have 5 carbon atoms here. If I go this way, 1, 2, 3, 4, 5, 6. But remember, you have to go this way because this is also a functional group on its own. I told you, this is alkanone functional group. So when you are counting, you must count to include all the carbon atoms bearing those functional groups. Does that make sense, right? So that being the case, the counting will go this way. Why I'm explaining this is if you go in this direction, 1, 2, 3, 4, 5, and 6. This CH3 in bracket is a substituent, so you don't count it among the parent. 1, 2, 3, 4, 5, 6. One would think that the longest chain is 6. But that would mean that you have cut off this guy that is a functional group. You have cut it off. You are meant to count in the direction to include all reactive functional groups. Alkanone functional group is more reactive than alkane. If you go in this direction, what you have here is single bond. So you go in this direction that contains this alkanone functional group. Therefore, this is going to be 4, and then what? 5. Take note of why I went in that direction. If you actually are checking the longest carbon, you should go this way: 1, 2, 3, 4, 5, 6. But I now told you that is why whenever you are learning organic chemistry in terms of the IUPAC nomenclature. It's not ideal to have a long list of rules or whatever, but thanks to God, I've actually covered all necessary things. In GMAETS 41 here, when you are talking about IUPAC nomenclature, all necessary kind of structure you can see, you can meet. I think I've covered most of them, yeah, up to a certain high level, so that as you follow up with the class, there is no structure you cannot analyze. I've told you why I picked 5 as being the longest instead of 6. Reason: counting must include all reactive functional groups. Those that are higher are more reactive than single bond. This is an alkanoic functional group. So the carbon atom them has to be counted among the parent chain. So if I had gone this way, I would cut off this guy, which is not correct. All right, having analyzed that, it means that this whole thing is an attachment. This whole thing is a substituent. It's a substituent. But I want you to look at the way this substituent is there. Look at it. Look at it. Normally, if you want to give the name of a substituent, you have to count the number of carbon atoms there. Like in this case, I have ethyl. How did I know that this is ethyl? This structure number 2. You will come to the parent carbon atom bearing that attachment. Then the carbon directly attached to that parent carbon bearing the attachment. That carbon will be given number 1. And then you count in the longest chain, this is number 2 of that substituent. So how many carbon atoms do we have as an attachment, as a substituent? 2 carbons. That is how I got to know that this is ethyl. In this case, you have 1 carbon directly attached to this carbon. So this is only 1, making it methyl. Anyway, let me remove this since I did not include it the first time. So what I'm trying to say in essence is, if you want to identify the number of carbon atoms in your substituent, you have to count. And the counting will start with the carbon attached to the carbon of the parent. For example, in this case, this carbon in the substituent, this is the carbon directly attached to the parent. Therefore, this will be carbon number 1 in the attachment part, in the substituent part. You will now determine the longest chain in that substituent part. Determine the direction of the longest chain. If you look at this carbon number 1, there are 2 directions here. This is one of it. 1, 2. And we have other carbons that is linked in the right-hand direction. 1, this is substituent in it. 2 and 3. So if I give you the room to count the longest chain in the attachment part, in the substituent part, will you go 1, 2 as the longest, which will not be ethyl? Or will you go 1, 2, 3 as the longest, which will not be propyl? You know, the whole thing here is an attachment. So correctly, we should go 1, 2, and what? 3. Because 3 is longer than what? 2. Which simply means that coming over here, this CH3 becomes a substituent, a sub-attachment in the whole attachment you have here. Look at this one. This guy in parentheses is also an attachment. Is also a substituent. So look at what we're trying to say. In the whole substituent part here, this side chain, the longest of it is 3 carbon atoms. In that 3 carbon atoms, you have 2 other sub-attachments. I call it substituent on a substituent, attachment on an attachment. In fact, the lesson under alkane, IUPAC nomenclature of alkane, I broke down this concept very well, and you can do well to visit the GMAETS 41's playlist on this channel, this particular channel, all right? At the end of the class, to learn more about that concept of attachment on an attachment, substituent on the substituent, I broke down everything you need to know about such type of structure. So look at this now. 1, 2, 3 is the main substituent on this parent. And this 1, 2, 3 substituent propyl, because 3 is prop. And as an attachment, alkyl, it's propyl. This 3 carbon atom substituent is on carbon number 3 of the parent. Take note of that. Is on carbon number 3 of the what? Parent. But observe that on carbon number 1 of these 3 substituent, on carbon number 1 of these 3 carbon substituent, look at it. You have this other attachment on an attachment, CH3. You also have this one attachment on an attachment. So this and this are attachment. They are substituent on carbon number 1 of our main attachment. It's just like I used to say, A gave birth to B. B now decided to give birth to C. You know that C will be attached to B, and then all this whole thing will now be attached to the main parent, A. So I've analyzed this. This is methyl attachment. This is methyl attachment. Both of the methyl attachments are found on carbon number 1 of our main substituent. 1, 2, 3 is the main substituent. These and these are sub-attachments, substituent on substituent, attachment on an attachment, and they are found on carbon number 1 of that side chain. If you want to give the name of this side chain, you have to put it in parentheses. That is the rule. That is the rule. Now let us go for the IUPAC nomenclature now. Let us go for the IUPAC nomenclature. Please watch. Are you there? The main substituent here is propene. Is propene. Let me see if I can write it here. This is propene. That's the main substituent. 3 carbon atoms. That propene is on carbon number 3 of the main parent. It's on carbon number 3 of the main parent. So you have to indicate it. Now, on carbon number 1 of this propene, we have methyl and we have methyl. 2 methyls there. I don't need to write it, no need. We have talked about methyl earlier. So we are saying that on carbon number 1 of the propyl, that propyl gives birth to 2 methyl. So do you see? This whole parent, 5 carbon atom, gave birth to this 3 carbon atom substituent, propyl. Then that propyl went ahead to give birth to methyl and methyl on carbon number 1. I think this, we have this attachment here. Then the next attachment is this guy. This is the next attachment. That's the next attachment or substituent. Oxygen is oxo, and that is on carbon number 4. So now let us give the name now, okay? Let's give the name. I'm going to ask you, if I give you dictionary now, and I said, okay, locate oxo for me. Look at this guy. You know that this thing is 1,1-dimethyl, because on carbon number 1 of the side chain of the substituent, you have 2 methyls there on carbon number 1, which is 1,1-dimethyl. That 1,1-dimethyl is attached to propyl. So if I give you methyl, this is what I'm trying to say. That side chain is actually 1,1-dimethyl, dimethylpropyl. Dimethylpropyl. This whole thing is attached to carbon number 3 of the parent. So if I give you this and I give you oxo, when you are checking in dictionary order, it is the attachment name you're interested in. This Latin word for 2, you don't consider it. Are you following, right? So in this case, you consider from M and O. So if you have M and O, which one will come first? Which one will come first? M will come first. Is that not so? Which means you have to pronounce this side chain attachment first before this oxo. But having shown you what to do here, let me ask you this question. Suppose this methyl attachment, they are not there. Methyl attachment is not there. That is just purely propyl. These 2 methyl attachment on carbon number 1, they are not there. And then this purely propyl. Propyl as an attachment and oxo as an attachment. Which one would you pronounce first? In alphabetical order, you will meet O before what? P. Which means you have to pronounce this attachment oxo first before you write propyl. But in this case, remember the propyl is bearing methyl. You will meet M before O. Which means in naming this guy, I have to name this attachment first before naming this one. I am done with all the analysis you need to know, please. I have to take time on this to explain this structure. Remember that this guy is on carbon number 3. This attachment on an attachment is on carbon number 3. So this is how the name of the parent will go. Locating that parent name, I will tell myself that on carbon number 3 of the parent, on the 3rd carbon atom of the parent, then open parenthesis. Parenthesis. If you are writing this name, this attachment, substituent on a substituent, the rule is that you have to put it in parentheses. So on the 3rd carbon atom of the parent, parenthesis, I have propyl attachment. But that propyl attachment on carbon number 1 of that propyl attachment, you have 2 methyl attachments there on carbon number 1. Look at it. So that's going to be 1, 1. Because the attachments are the same on carbon number 1, you will repeat that 1, 1 using comma to separate. So you see, between numbers, you use comma to separate. Since there are 2 of the methyls, it will be di, then methyl, dimethyl, propyl, propyl, propyl. Close the parenthesis. Close the parenthesis. You are done with that side chain. That substituent on a substituent. Remember the rule. Substituent on the substituent must be in parentheses. Then we move on. We are done with this. I'll now come to this. On the 4th carbon atom, put hyphen. Between letters and a number, you have hyphen. On the 4th carbon atom of the parent, you have oxygen attachment, which is oxo. That is all about the attachment, the substituent. And so we are going to move on to the parent name now. This is 5 carbon atoms. 5 carbon atom prefix is pent. Prefix is pent, pent, pent. But take note that within the parent carbon skeleton, you have double bond somewhere. If there is no double bond here, suppose there is no double bond, this could have been something like pentanoic acid. But because of the double bond, you have to break that bond, that pent from the ending part, the suffix. So just like we did here, this is going to be pent. You indicate the carbon atom bearing the double bond, which is 2. Pent 2 enoic, enoic acid. Pent 2 enoic acid. That is the name of that structure there, the IUPAC nomenclature. 3 into 1, 1 dimethyl propyl, 4 oxo pent 2 enoic acid. All right, we have taken time to analyze this structure. We have taken time to analyze this structure, and I hope you understood what I explained there. To some of you, this might be your first time of meeting a structure like this. This might be the first time of meeting a structure like this, and it's all good. I've done the analysis for you. If you have any question, you can type your question below. I didn't understand. Izuchukwu Joshua, when did you connect to the class? Did you follow up from beginning when I was explaining that? If you just come in to meet the class and you could just be patient, much later you still retake the lesson. Izuchukwu? Is that okay? You can retake the lesson. And please, for the concept of substituent and substituent, I shouldn't be really spending much time explaining this concept again. I've told you this is what you should do. If you want to understand all the concepts of IUPAC nomenclature, take the video lesson on this channel, Chem 102 playlist, because that Chem 102 is purely organic chemistry. Take the video lesson on IUPAC nomenclature of alkane. Take the video lesson on IUPAC nomenclature of alkene. Once you take these 2 video lessons, your problem is solved. Your problem in IUPAC nomenclature is solved. Yes, that is it. Any other thing that is being done, you can follow up easily with it. Let us move on. We are done with this alkanoic acid. We are done with this alkanoic acid. Just look at this one. Look at this one quickly. Let's say this is number 5. I've got this COOH and then COOH. Yeah. Look at this guy. How do you name this? It's simple. First of all, notice that we have 2 carbon atoms there, and 2 carbon atom prefix is it, however you want to call it, right? As in ethane, it. However, notice that the functional group here is alkanoic acid. Alkanoic acid, carboxylic acid, COOH. How many COOH do we have here? 2, which is dioic. All these guys you've been saying oic. If we had a place where we have 2 COOH, the name would be, like in this case, pentane dioic acid, if you have 2 COOH in the structure. So since we have 2 COOH here to be dioic, And then remember, I have 2 carbons going to ethane. So this is ethane dioic acid. Ethane dioic acid. That's the way you name this. Is that okay? If it is something like this, I'm going to wipe this one. If it is something like this, so it will be something like this. It will be propane trioic. Propane trioic acid. I'm just trying to explain further, what I did here. So take note of that. If you have, 2 COOH in a structure, the way you name the parent, you name it as an alkane and then dioic. That's what we did here. 2 carbon atoms, ethane. Because of the 2 COOH to now be dioic and then acid. That is cool. We are done with this structure. Copy it out. You can screenshot in order to be fast, so that I would wipe the board and then we move on to the next homologue. We move on to the next homologue, which is a derivative of alkanoic acid. We'll move on to the next homologue, which is a derivative of alkanoic acid. So I'm going to wipe now. Let me adjust this. It's going to cut off the right side. Okay, so trying to adjust the camera. All right, so we are going to move on to the next homologue. I'm wiping this. The next homologue is actually a derivative of alkanoic acid. A derivative of alkanoic acid, that's to say we get it from alkanoic acid. Are you following, right? We get it from alkanoic acid, and that derivative is esters. Esters. That esters, they are called alkanoids. In fact, let me write alkanoid first. Alkanoids. Then specifically, the alkanoids we are treating, the ones you treat in IUPAC nomenclature is esters. I'm saying this because all esters are alkanoids, but not all alkanoids are esters. Not all alkanoids are esters. For example, I can have something like calcium propanoate. Calcium propanoate. That guy is an alkanoid, but not an ester. For you to get an ester, because esters are obtained from esterification reaction, the reaction between alkanoic acid and alkanol in the presence of tetraoxosulfate 6, that reaction is reversible, I guess, right? Okay. So those ones you get, their name is, the way you name their parent is actually alkyl alkanoate. Alkyl alkanoate. You don't have any metal there. So those ones properly are esters. Now, what is the functional group of this guy? Just as a reminder, the functional group is RCOOR. And let me put a prime here. This prime I put here, don't get confused. Those R there, they are chains of carbon. R and R prime, the reason I put that is to tell you that the 2 carbon chains on left and right, they might be the same. They might also be different. So you want to take note that R may be equal to R prime, or R may not be equal to R prime. For example, it's possible for this to be methyl, right? Maybe the number of carbon atoms here to be the same as the one you have here. It's possible that the number of carbon may not be the same. So it doesn't matter. Don't get yourself confused. Just remember that on the left you have chains of carbon, on the right you have chains of carbon. How do you name the parent of this guy? Parent name follows this pattern. Because it's very important whenever you are dealing with IUPAC nomenclature to know the pattern of the parent name. Parent name Parent name pattern or pattern of the parent name. Parent's name pattern. Parent's name pattern. The way we name it in IUPAC nomenclature is alkyl alkanoate. Alkyl alkanoate. Alkyl alkanoate. If there's any attachment, you deal with the attachment as it should be. Now, this is the pattern you name the parent of this guy. Now, the alkyl is obtained from this part, and the alkanoate is obtained from this part. Is that okay? This is the OH part, and this is the alkyl part. This OR prime comes from, that OR prime comes from alkanol during the esterification reaction process. Then the RCO comes from the alkanoic acid. So if you are naming the result, the esters obtained, it's going to be starting from that alkanol part. You name it as alkyl. Then you conclude with alkanoate from the left-hand side. So it means that since you are naming the alkyl part first and then alkanoate, whenever you are dealing with this, you number left and right. Okay? So don't worry, we're going to pick structures and then we deal with it and what we have there. We are moving on. Let us look at this one now. Let's look at this one. So the first structure I've got here, let me make it structure number 1 still, since it is a different homologue we are treating now. So I've got this CH3, CH2, then COO, CH3. You know, this simple one. This simple one. So what do you do? Quickly split this into 2 here. If you're giving the IUPAC nomenclature, I've just explained that. You have to know the alkanoic acid part and the alkanol part. Then you number left and right. If you want to number, starting from this carbon, you numbering this way. This is carbon number 1. If you have other carbons, you continue numbering. Then coming to the alkanoic acid part, the alkanoate part. Starting from this carbon, you have number 1, then 2 and 3. Are you saying that right? Then you name this part first. This part is the alkyl part. And then you name this part, ending it. This is the alkanoate part. Alkanoate part. So you now have alkyl alkanoate. The question will now be, what is the name of this alkyl? This is 1 carbon. 1 carbon as an alkyl is methyl. And then what about this alkanoate part? What is the name of the alkanoate part? Simply check the number of carbon atoms. There are 3 of them. 3 is prop. And then you know you are naming as alkanoate. So it's going to be propanoate. And so the name of this guy is, the IUPAC nomenclature is methyl. Methyl from here, and then propanoate. Propanoate on the other side. If you have attachment, substituent, you deal with the substituent as it could be. If you have a substituent on this part, that substituent to be attached here first. And then if you have substituent on the other part, before the propanoate, you now indicate, analyze the substituent, the attachment, and then indicate there. Don't worry, we are moving on. We are going to learn more about it. Okay? We are going to learn more about that. Yeah, do chemical kinetics. On this channel, you have video lessons already on chemical kinetics. How do you get it? Slide through to the GMAETS 41's playlist on this channel. Locate Chem 101. Locate Chem 101. Scroll through that playlist. You see wonderful lessons on chemical kinetics. I've told you guys, this channel is an academic wonder. There is something this channel is targeting. And that's just what I want to do for you guys. Build an online academic library made with video lessons where scholars can come and get, to improve their level of learning. Do you get that right? So most of all these lessons you guys are requesting for, they're already here in this channel. I've told you, make use of this playlist very well. And become a channel member, please. Become a channel member. In this live session going on now, you would see around that chat box, By the right, you would see your currency icon. I think it's the dollar icon there. All right. See that currency icon. And then you can support GMAETS 41. You can support GMAETS 41. And then become a channel member, like I said. Become a channel member. Join the GMAETS 41 on platinum level or diamond level in order to get access to members only video. Because most of all these videos are meant for members. Yes, because a lot of work goes into it, and a little appreciation would not do you any harm. Our membership package is a 1 month package, so you can just imagine, right? Like in Nigerian currency, because that's where I'm streaming from right now. The monthly package in platinum is 2,000 naira. So if you're connecting from any other part of the world, convert to your currency, and that will give you a 1 month access to all the lessons available on this channel. That would also make it possible for you to make personal requests, you know, what you want me to do for you, and then I'll attend to it. But remember, you can join our WhatsApp group so that you make your requests there. Become a channel member. Send a message to me on this contact. Your full name, where you are contacting from, your level of learning. Then if you become a channel member and you're making all these your personal requests, I will attend to it fully. Don't you pay school fees in your schools? You pay school fees, right? So you see why you should support me more by becoming a channel member. I'll appreciate that, guys, all right? I know it has to be convenient for you. I'll really appreciate that. We move on to structure number 2. I've got this for you. CH3, CH2, CH, Br. Then CH2, CH, CH3. I've got this, something like this. Then O, and then C2, H5. I hope this has not cut off from the board. This C2H5, actually, it was expanded. I decided to just condense it because of, because of space. Because of space. It was actually written like, after this bond line from oxygen, then I have CH2 and then CH3. This and this, they are the same thing, okay? They are the same thing. Let me check and be sure that this has not cut off from view. Okay, it's there. Does not cut off from view. Does not cut off from view. All right, what fix you asked? Price. Like I said, once you click the join tab on this channel, if you click the join tab, you would see the packages available on the GMAETS 41's channel. We have packages of 2,000. Yeah, if you are joining the channel, please, so that you would get access to all the video lessons. Join from platinum level, join at diamond level. Platinum level is 2,000 naira Nigerian currency monthly. Diamond level is 4,000 Nigerian currency, still monthly. So once you become a channel member, you're only doing a monthly renewal. Imagine 2,000 naira in a whole month. It's something, it's not much, right? It's not much. I will really appreciate that. Okay, so I am moving on. This is the structure. I've told you that really this guy was expanded, but I had to compress it so that it won't cut off from view. CH2, CH3 is the same as C2H5. So what do you do quickly? Remember this C doubly bonded to this oxygen and then O to this C2H5 is the same as COOR. COOR prime. Are you following, right? So this part is from the alkanol. What do? You split. Here will be the alkyl part. Alkyl part. This part will be the what? The alkyl part. You know, like I said, you always split between the two oxygens. Then this part, this whole part now, is the alkanoate part. Alkanoate part. Alkyl, alkanoate. This alkyl, 2 carbon atom, is E. So ethyl, ethyl. Then coming here now, let's count the number of carbon atoms you have here. Here is 2 carbons clearly. Here we have, okay, let me indicate 1 and 2 carbon. 1 and 2. Anyway, it doesn't matter. You listen when I explain it. There are 2 carbons that you can see that. So that is ethyl. And then coming over here, right? How many carbons do you have? Let's number 1, 2, 3, 4, 5, and what? 6. All right. Remember I told you this guy is also a terminal functional group. Alkanoic. The functional group is a terminal. So in determining carbon number 1, you always go to that part where you have that functional group, COO, prime. All right. You go there. From here, you check your carbon number 1 to the right. From here, this is carbon number 1 to the left. Now notice that we've got attachments. And what are the attachments? This is an attachment, CH3, which is methyl. This is an attachment, Br, bromine, which of course as an attachment, you name it as bromo. And that is it. So how do we attack the IUPAC nomenclature here? As usual, mention the alkyl part first. In the alkyl part, there is no attachment given. There is no attachment, so just simply CH, CH2, and then CH3, as I showed you earlier, which I wiped. So mentioning that alkyl part, we are going to have ethyl. Then you come to the alkanoate part. This is 6 carbon atom. It's meant to be hexanoate. However, observe that you have attachments in that hexanoate part. So the first attachment is methyl here. The second is bromine, which is bromo. Following alphabetical order to know the one you pronounce first. M and B. B comes before. Are you following? So you're going to mention bromo on the 4th carbon atom of the parent before methyl on the 2nd carbon atom of the parent. So this is going to give us ethyl. Are you there? Then hyphen on the 4th carbon atom of the parent on the alkanoate part. 4th carbon atom of the parent on the alkanoate part. You have bromo. You have what? Bromo. Okay. You have bromo. Then on the 2nd carbon atom of that alkanoate part, you have methyl. You have methyl. And no other substituent. So you conclude with the parent name, which is hexanoate. Hexanoate. Hexanoate on that left hand side. So this is ethyl 4-bromo-2-methyl hexanoate. And you can see how simple we handle this. Now I want to say that it is possible for this guy to have its own attachment. And if the alkyl part has an attachment, you have to also handle the attachment on that part, before that alkyl naming. Let's see if I've got a structure for you like that in this case. Let's see if I've got a structure for you. Okay. So let us look at this. Let us look at this. I'm going to wipe these parts. Now I'm going to give you this structure. I really don't have any of such here, where the alkyl part will also have its own attachment. So let me create one for you. Let me see the view of the camera and check if I have got to make some adjustment. Okay, I think I've got to make some adjustments. So be patient. Or should I leave it? Should I leave that? Let's see. Let me see if I can squeeze out something here. But it's not possible. It's not possible. The space will be too small to occupy the attachment. So finish up what you have there. Let me adjust, please. Finish up what you have there. Let me adjust. Can screenshot, please. Can screenshot, and then let's look at this now. I'm going to adjust. So I'm giving you this structure. Let us say we have, that's number 3. Let's say I give you CH3, then CH, and I've got CH3. I've got, let's say, Cl, and then I have this COO. Then I give you CH, then I now have CH3. And I give you CH. Let's say I have CH3. Okay, so something like this. Now what do? Quickly observe the functional group that you have COO. COOC. That's simply the alkyl part. So that tells you that you're dealing with alkanoid. As a matter of fact, it's only alkanoid that has that COO something, okay? And therefore, you come over here and then you split into two. You have the alkanol part, which is the alkyl part, if you are naming the parent. And then you have the alkanoid part, the alkanoid part. With this, you number. See, all these things I'm trying to do is just to guide you, for you to follow through. In exam, you don't need to be splitting all these things. And alkyl and alkanoid, no. You already have these at heart already. Okay, so coming over here, you have one. Carbon number one. Then you decide if you go this way, would that be the longest? Or if you come this way, would that be the longest? So you see 1, 2. 1, 2. So any direction you take, you're going to get 2 carbon atoms. So you can take any one of them. I'm going this way so that this becomes a substituent on that alkyl there. Then coming here, you have 1 and then 2. And if you look at this, 1, 2, 1, 2. Now, this second carbon atom, you can go here 3, or you can come here 3. In either case, the other guy becomes an attachment. Anytime the straight chain is the same in number as the branch chain, I usually take the straight chain as the longest. But you can still decide to come like this. Anyway, let me come like this, 3, and then take this one as an attachment. Since this one, I went straight and took this as an attachment, let me use this branch now. Since the branch chain is the same in number as the straight chain. So we have 3 carbon atoms in the alkanoid part, 2 carbon atoms in the what? In the alkyl part. Good. Therefore, that leaves us this as an attachment, this chlorine as an attachment, this one as also a substituent, an attachment. So remember the rule, you start from the right-hand side, the alkyl part. And in that alkyl part, we have, on the first carbon atom, we have methyl. So this is going to be 1 methyl attached to ethyl, 1 methyl ethyl, because 2 carbon atom is ethyl. 2 carbon atom is ethyl. On the first carbon atom of that ethyl, you have CH3 attachment, which is methyl, giving us 1 methyl ethyl. You are done analyzing this alkyl part, that guy that comes from alkanol during the esterification reaction. And then we are now moving on to the alkanoic part, the guy that comes from alkanoic acid during the esterification reaction. Now you notice you have 3 carbon atoms. On the second carbon atom, you have 2 attachments there, this and this. This is chloro, this is methyl. And so you have to go with chloro first. So I'm going to write hyphen. Then we have 2 chloro, 2 chloro, 2 chloro, you fix hyphen. On that same carbon number 2, you have methyl attachment, 2 methyl, 2 methyl. And I think that's all about the attachment. That's all about the attachment. You can now conclude with the parent name. All right. Remember, you have highlighted the parent name here, the alkyl, which is this ethyl, 2 carbon atom. What you are doing here now, 2 chloro, 2 methyl, has to end with alkanoid. And what alkanoid do we have here? 3 carbon atom is prop. So it's now going to be propanoate. Propanoate. That is how you give the name of that structure. That's how you give the name of that structure. Izuchukwu, how did the ethyl come about? The ethyl here, if you're asking a question based on this, is it based on this number 3? If it is, the ethyl is based on the fact that you have 2 carbon atoms here in the alkyl part. 2 carbon atoms. If it is this ethyl you are talking about, it is because on this right-hand side, the alkyl part, you have 2 carbons. Look at this, C2. There are 2 carbons. And I told you earlier that this was actually expanded CH2, CH3. But your examiner decides, however, to present this, whether in condensed form or to expand it. So 2 carbon atom brought the ethyl in structure number 2. Then here 2 carbon atoms brought the ethyl in structure number 3. Chiagozi Andrew, you don't understand. What is it you don't understand? Be specific in your question. If you just come up and say, I don't understand, I just don't know where I would start from. What is it that you don't understand? Be specific. Okay, me too. Chiagozi Andrew, you don't, me too do what? Is it that you two now understand, like Izuchukwu said, I understand now? Okay, let me assume that you mean you understand now. So we are done with this homologue. we are done with this homologue. I'm going to give you a moment to screenshot it, okay, or you copy it out, and we're going to move on to the next structure or the next homologue. We're going to move to the next homologue. Finish up that on the board. Finish up that on the board. Okay, Andrew, I get you now. You've typed clearly. Finish that on the board so that we move on to the next homologue. The next homologue would be the acid chloride. The next homologue will be the acid chloride. The acid chloride are derivatives. It's also another derivative of alkanoic acid. Acid chloride is another derivative of alkanoic acid. When you are dealing with alkanoic acid, after that, there are 4 derivatives. There are 4 derivatives, 4 pikins, 4 children that alkanoic acid gave birth to. All right, there are 4 of them. The 4, we have treated 1, esters, alkanoid. The second is acid chloride. The third is acid amide. The fourth is acid anhydride. All right, guys, let's assume that you are done copying and or screenshotting what you have on the board. So I'm going to wipe the board. I'm adjusting this now. I'm adjusting so I can wipe the board. Adjusting, and then I'm going to wipe the board. We are done with esters. Remember, at the end of this live class, a copy of this video is going to be made available. Therefore, you can always check back. You know, you can always check back. On this channel, always check back. If you have not subscribed yet, I don't know what is holding you. And if you have subscribed and you have not turned on your notification bell, I don't know what is holding you. Now, I've been talking about supporting this channel, but at least subscription now, that one are free of charge. Subscription is free. Turning on notification bell is free. What does that do for you? It helps you so that if your creator uploads any content, YouTube will notify you. Are you following, right? If your creator uploads any video, any content, you will be notified. So at least that one does not cost you anything. You don't pay anything to subscribe, to turn on notification bell. You have to do that, so you'll be following up with my classes. Is that okay? Because of course, you know, there is no way each of you can be contacted by me. Hey, today we are taking class and other things. But then you can also join our WhatsApp group. Like I said, send a message to me and you will be added to our WhatsApp group. But of course, you have to become a member. Very important. Platinum level or diamond level will be appreciated. Let us look at the next, I said, acid chloride. We're going to look at acid chloride. That's the next homologue that I'll be teaching you, acid chloride. So for acid chloride, what should you know about that? Acid chloride. Acid chloride is also called acid. It's called acid chloride, ACYL. That acid is from this guy. Look at this guy you are seeing here. This guy you are seeing here is called the acid group. The acid group. Okay, yeah, you can call it that way. So acid chloride, acid chloride, whatever. What is the functional group of this guy? The functional group is actually COCl. The functional group is COCl. This oxygen you're seeing here is doubly bonded to this carbon. It's doubly bonded to this carbon, so it's something like this. If you choose to expand it. This particular functional group, I did not list it in our previous class. Because that previous class, I actually did a kind of general stuff. And then I was much more concerned about our JAM students and, WIC students. By the way, to you dear friends taking your JAM mock today, your practice test. Because JAM mock is a practice test. GMAETS 41 is wishing you all the best success in your practice test. I'm not calling it examination. I'm not calling it examination because That is just JAM test. It's not a true test of what, it's not a reflection of what the main exam is going to be. So take note. I wish you the best. It's just like you're going to, okay, let's see how you make use of the system, you know, answer some question. I know JAM is going to give you results on that, but even if you score 500 over 400, don't be deceived. Still work hard for the main exam. Are you following? Your JAM mark is not a reflection of your main exam question. Anyway, remember what we are dealing with in this particular live class is based on advanced level. Yeah, it's based on advanced level, and that is why these other functional groups are now appearing. I said it in that previous class. When I listed those other functional groups, I made a reference to people in advanced level. I told them, please do not be limited by those functional groups. There are still other ones that you need to know. So that is it. Now, what is the pattern of the parent name? Pattern of the parent name. Pattern of the parent name. Pattern of the parent name. That is how you give the name of the parent. Like I said, it's very important. You must always know that. Now, the parent name of this acid chloride, they go as alkanoil chloride. Alkanoil. Alkanoic chloride. So however you are naming this guy, however you are naming it, the parent name will be alkanoic chloride. So it has stuff like methanoic chloride, ethanoic chloride, propanoic chloride. Don't be annoyed though. Don't be what? Annoyed. All right, so that's it. Non-anoic chloride, decanoic chloride, right? Eicosanoic chloride. Trade carbon atom is called what? Eicosane. Don't worry, nobody's going to threaten you with that. Those in advanced level, the highest number of carbon chain you can ever meet is 10 carbon atom. That is if you even see up to that. If you even see up to that. But don't mind me, I just try to make you know that we still have much more longer carbons. Okay, so I've given you the pattern of the parent name. Every other thing as to how you handle the attachment and stuff like that, they are the same. Okay, so you already know how to handle the attachment and stuff like that. Our first carbon, we've got this. Number one, is our first carbon or first structure. I've got this simple one for you. Let me assume that someone gives you HCOCl. HCOCl. You know, how do you give the name of this guy? So quickly, count the carbon atom you have there. Here, this is the carbon atom, and this is the only carbon atom you have. One carbon atom. Now, what is the prefix of one carbon atom? The prefix of one carbon atom is meth. Meth. And remember, like I told you, the name of the parent goes as alkanoic chloride. Melta. So, methanoil chloride. That's the name of this guy. Methanoil chloride. They must end with chloride, just like alkanoic acid must end with acid. Number two, and of course, that is why you don't take this chlorine as an attachment. You don't, because within the parent name, that chloride exists or appears there already. So it is not an attachment. You take note of that. And that's why I told you, see, this COCl, this functional group is also a terminal functional group. Whenever you see it in a structure, that carbon will always be carbon number one. Every other stuff there will be taken as an attachment. You know, every other functional group will be taken as an attachment. Let's look at this number two. No time. Good. I've got this wonderful structure, very long, very long. So the second structure I want us to deal with, number two, CH3, CH2. Okay. Now, number two is not the one that is very longer. Let me even give you that one that is very long, no problem. Or should I pity you, give you this guy first? Okay, let's look at this. CH3 here. And then this is CH2. We've got something like this. Let me refresh your ministry a little before we go to the other one. Okay, so simply we move on. This is carbon number one, no time to waste. This is number two, this is number three, this is number four, this is number five. You know, if you go 1, 2, 3 and you come down 4, 4 is not as long as 5. Therefore, the longest chain is 5. This becomes what? A substituent. 5 carbon atom prefix is pent. Now, because this is an acid chloride, you can see the functional group COCl. All right, this is an acid chloride. It therefore means that we are going to get the name in the alkanoic chloride concept. 5 carbon atom parent is pentanoid. Now, on the 3rd carbon atom, you have an attachment. So you have to mention that substituent first. On the 3rd carbon atom of the parent, you have methyl attachment. So it becomes 3-methyl. No other substituent. So you name the parent. 5 carbon atom is pent. Oh no, there is no hyphen here. There is no hyphen. You don't put hyphen between alphabet. You don't. It's between number and alphabet. You include hyphen. Then between numbers, you put comma. 3-methyl. Parent name is pentanoid. Pentanoid chloride. Pentanoid chloride. That is it. That is it. All right, let's see. Someone attempted. Aditya Shaurya, right? Aditya Shaurya. You can always correct me with the pronunciation of your names. I don't okay, no, you're not the one that's it. You already gave the name pentanoid chloride. That's very good. But take note, the pentanoid chloride is the name of the parent. You must indicate the attachment first. This CH3 on number 3, carbon number 3, is a substituent. So you mention it first, 3-methyl pentanoid chloride. So kudos for coming up with that pentanoid chloride. Chiagozie Andrew, 3-methyl pentanoid chloride. That's good. But in your name, 3-methyl, you had to put comma between the methyl and pentanoic. And I could see pentanoic. Please. Andrew, take note, okay? Take note. What I'm seeing from your comment here is pentanoic chloride. This is not oic. It is not oic. Rather, it is oil. Oil. O-Y-L. Noil, if you want to. Noil. N-O-Y-L. Not O-I-C. Therefore, that guy is not pentanoic. If it is theory now and you give this name, you would have problem. You know, the teacher can show you some mercy, give you some scores, correct you where you made a mistake. Some examiners might be very strict and they could just fail you. However, if it is an objective case, for example, assuming you have this your name there. Okay, yeah, you say something now. Okay, sir, it's a mistake. That's good. All right. So you correct it. The functional group we are dealing with now, the parent name is not oic, oil chloride. So take note of that. But you guys are doing well. You're trying. That's good. Aditya, that's good. You gave the parent name correctly, but I didn't see this your attachment. Now we are moving on, please. Let's look at the next structure. I am going to adjust the camera to capture this side. That next structure is not funny. It's not funny. But don't worry. When I say it's not funny, it doesn't mean it is difficult. From the GMAETS 41's platform here, I don't believe that anything is quite difficult, right? It can be tough. But the truth is, you can resolve it. You can resolve it. You've already been given all the protocols, the principles, and stuff like that. So what is that? Apply the principles and you have your structure being named. So that takes us to number 3. Number 3. Structure number 3. Which, of course, is likely the last structure for this guy. And then we move on to acid amide. So this is what we have here, CH3. I hope I can compress this to enter because the carbon atoms, they are so long. This is CH3, CH3. And then we have CH2, then C, there's CH3, and then here we've got C, we have OH, and then we have CH3 here, we've got CH3 here. And then moving on, I have CH2, I have CH2, I have CH2, and then I have COCl. I have COCl. All right, so that's the structure. That's the structure. That's the structure. I hope you captured it. That's good. Everything is showing there on the screen. So let us see how you handle this particular structure. Let's see how you handle this structure. Remember the rule, first of all, determine the functional group, the operating functional group there. If you look at this, we have this COCl. That's the functional group. See, we have OH here. OH is the functional group of alkanol. OH is the functional group of alkanol. But would you not be naming this as an alkanol? You can't do that. The reason is simply COCl as a functional group supersedes OH as a functional group. And the basic reason, because if I talk about supersede, sometimes maybe a student might be worried. How will I know the one that supersedes? How would I know? So I guess the best thing you want to always think of is get to know the functional groups that are terminal functional groups. COCl, right? The acid chloride functional group, they are terminal functional groups. Alkanoic acid is terminal. Anytime you see them, they are the operating functional group. Acid chloride is terminal. Anytime you see them, they are operating functional group. The esters, that is alkanoids, that guy is a terminal functional group. Anytime you see them, as you split between the two oxygens, right, that first carbon is number 1, left, that first carbon is number 1. You know, we've just treated that. Then the next one, acid amide. After this one, the next derivative of alkanoic acid is going to be acid amide. That also is a terminal functional group. Then alkanal. Alkanal is a terminal functional group. Anytime you see that functional group, that guy is what you will respect as carbon number 1, and hence the parent name will end with that homologue name. So now I have listed terminal functional group. That will serve as a guide. Anytime you see them and you see any other functional group, that any other functional group is considered an attachment, a substituent. So here I have COCl. So this is going to be an alkanoic chloride group. Now let us determine the longest carbon chain. This carbon of the COCl would definitely be number 1. And then if you go 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 is the longest, clearly, as you can see. 4, 5, 6, 7, 8, and what? 9. Which means, however you name this guy, the parent name is going to be non-anoyl. Non-anoyl chloride. Remember, 9 carbon atom is non, the prefix. If it is alkane, it will be nonane, at least the one you are very well used to. Converting that nonane to alkanoic chloride, that is acid chloride homologue, because nonane is alkane. So all you have to do is to remove the suffix a, then transfer it to acid chloride, which I told you the parent name in the case of IUPAC nomenclature is alkanoic chloride. So if you come to nonane, remove that a, pick the non, then attach the anoy, non-nanoy chloride. All right. Having said that, this guy becomes an attachment, a substituent, then this whole thing is substituent. But I'd like you to observe something. This substituent, this and this, they are the same, very simple. They are methyl. So we have trimethyl here, right? We have trimethyl, which is 3 methyls. Now come to this substituent down here on carbon number 5 of the parent. You will notice something, that this carbon is directly attached to the parent. So in this part, this will be carbon number 1 of the side chain. We can determine the longest carbon here because there are branches. There are carbon branches from this particular carbon that is attached to the parent carbon. You can go this way, 1, 2. Or you can go this way, 1, 2. Since there are branches from this carbon that is an attachment on carbon number 5 of the parent, you must count the longest carbon chain in the branches. We've done something like that in the last structure under alkanoic acid. So you come here 1, 2, or you can go 1, 2. If you have any other direction, maybe that has 3 carbon atoms, they're not going to have 1, 2, 3. But the carbon did not extend up to 3 carbons. They have 1, 2, or 1, 2. So if I go 1, 2, this becomes an attachment, this becomes an attachment. If I come down 1, 2, this becomes an attachment, this becomes an attachment. The choice is yours. Now I want to go 1, 2 down. If I go 1, 2 down, it means this whole attachment is 2 carbon attachment. It means that this whole attachment is 2 carbon attachment and 2 carbon substituent. Where I have carbon-carbon substituent, 2 of it is ethyl. So you have that on the 5th carbon atom of the parent, there is an ethyl attachment. But looking at this ethyl attachment, we have 2 other attachments on carbon number 1. This methyl and this hydroxyl. So this is an attachment on another attachment. This is an attachment on another attachment. Is it clearly this long chain, the parent chain, number 5 of it gave birth to these 2 carbon attachments. Then these 2 carbon attachments, which is ethyl, went ahead and gave birth to methyl attachment and hydroxyl attachment on carbon number 1 of that side chain, of that attachment. All right, so that's just how you analyze it. What I'm trying to say is that if I want to give the name of this guy now, for example, let me just write it here. I will say that on the 5th carbon atom of the parent, then I'll open a parenthesis. Why am I opening parenthesis? Bracket. Because this is substituent on substituent. And what is the name of this substituent and substituent IUPAC name? The IUPAC name would be on the 1st carbon atom, you have methyl attachment, you have hydroxyl. OH as an attachment is pronounced hydroxyl. Methyl, L, hydroxyl, H, which will come first. Hydroxyl will come first. So 1 hydroxyl, 1 hydroxyl, 1 methyl, 1 methyl. Now this attachment you are seeing, they are attached on ethyl. They are attached on what? Ethyl. This is meant to be in parentheses whenever you're writing the IUPAC name. Then outside you indicate the parent carbon bearing it. So for this, the name is 1 hydroxyl, 1 methyl, ethyl. Ethyl gave birth to this 1 hydroxyl, 1 methyl. That ethyl is these 2 carbon atoms attached to carbon number 5. Okay, then this is methyl, this is methyl, this is methyl. Now I'm going to ask you this question. We have methyl, methyl, methyl attachment, and we have this hydroxyl methyl attachment. Now, if I give you dictionary, alphabetical order, to search for methyl as an attachment, and to search for hydroxyl, because in this side chain, hydroxyl is the first attachment you have there, right, in the naming pattern. H and M, which will come first. H will come first, which means we have to mention this substituent first, this attachment. We have to mention it first before mentioning the other 3 methyls. Okay, so having analyzed that, let's go. On the 5th carbon atom, on the 5th carbon atom of the parent, then parenthesis, you have 1 hydroxyl, 1 hydroxyl, 1 methyl, 1 methyl, and these guys are attached to ethyl. You put it in parenthesis, you close it. Then you move on, hyphen. On the 5th carbon atom, on the 7th carbon atom, you have methyl attachments. 1 of the methyl attachments on the 5th carbon atom. 2 of the methyl attachment on the 7th carbon atom. So that's going to be 5. Since the attachments are the same, methyl, 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 you will follow the positions of the parent carbon bearing this attachment. You will follow them up. Are you following, right? At the same time. So 5, 7, 7. You are going to repeat that 7. Why are you repeating it? To tell anybody looking at this or reading this IUPAC name, to tell the person that on the 7th carbon atom, you have 2 of the methyl attachment there. That is why you have to repeat that 7, 7. Okay? So we have 5, 7, 7. 3 of the methyls is tri. You use the Latin word for 3, which is tri. Trimethyl, because there are 3 methyls. Now there is no other attachment. There is no other substituent. Did you take that this substituent, I didn't put it in brackets. I did not. Because these substituents are attached to the parent directly. They did not give birth. They did not give birth to another attachment. This substituent did not give birth to another attachment like this one gave. Like this one gave. No, these ones, they gave birth to methyl and hydroxyl. That is the idea of attachment on an attachment. These ones, they are directly attached to the parent without giving birth to their own substituent. So you don't put those ones in parentheses, you don't. The one that you include in parentheses is the one that gave birth to its own Substituent. That's an attachment and on an attachment. Watch. This methyl, ethyl rather, this ethyl, 2 carbon atom is attached directly to carbon number 5 of the parent. Then the ethyl now went ahead and gave birth to these 2 other attachments. All right, guys, we are done. The longest carbon chain is 9. So that's going to be non-annoy chloride. You love that? So that's the name of this structure. Now, I want to say this before we move on to acid amide. Let us assume that between maybe 2 carbon atoms, you have a double bond. Like that thing we met under alkanoic acid, where I told you enoic acid. I told you something about enoic acid. Let us assume that I have a double bond somewhere. For example, say I have a double bond between carbon number 3 and carbon number 4. In that case, carbon number 3 will now be assigned that double bond. So if you are given the name of this, the parent name will now take this format. Alk, something enoy chloride. Something enoy chloride. That something is the position of that double bond. For example, like I said, if I have double bond on carbon number 3, this will now be you break. Indicate the carbon atom bearing the double bond, which is 3. Non-3, then enoy chloride. So that's how the name will go. No longer annoy. If it is A, single bond, then no need of breaking anything to indicate the carbon bearing the single bond. It will be non-annoy, like you have it there, A. But if you have a double bond alkene in the parent carbon skeleton, you must respect that. And that's, like I said, assuming you have double bond after carbon number 3, it will now be non-3. E will come in. Enoy, to respect alkene, enoy chloride. So you take note of that in case you see any such structure, because I wouldn't consider any such. All right. So finish up with what you have there on the board. Let me wipe it. Finish up with what you have on the board. Okay, Chiagozi Andrew, you attempted this, and I could see 5 into 1 hydroxy 1 methyl ethyl hyphen 577 trimethyl non-annoy chloride. That's very good. Thumbs up. Okay, thumbs up. I hope you friends are sharing the link to this particular live class to your friends. I would always appreciate that. Share the links to the GMAT 41's video lessons to your friends. Encourage them to join us. All right? Encourage them to join us. Tell them about the goodness, right? About the quality of what you learn from you. Sometimes people would just want to hear, okay, why are you telling me to go and subscribe to this channel? And important for you to also know that GMAT 41 has a special channel dedicated to our basic level of learning. That channel, the name is GMAT 41's Basic Class Channel. GMAT 41's Basic Class Channel. You can search for it on YouTube. GMAT 41. Don't put hyphen between the GMAT and the 41 like you have in this particular channel. Don't put hyphen. Type it once, GMAT 41 together. 41. All right. GMAETS 41, then you shift, space, basic, space again, class. By 12 o'clock, just shortly after this class, I'll be holding a live class on basic board maths, combined operation in that channel. In fact, let me type the name of the channel. I want to type now. I'm using that channel to actually kind of observe what is happening from your end. So what I'm going to post, the name of the channel, it is the channel itself that is posting that name now, GMAT. So you get to know it. I would like you to go and subscribe to it, please. Especially for those of you that have challenges with, calculation generally, because you have to go and start from a certain level, basic level, to upgrade your calculation skill. GMAT 41 basic class. All right. That's our basic class channel. Our basic class channel. Channel name. So I am dropping it now. GMAETS 41's basic class. Please subscribe to that channel. Subscribe. I know that most of you are in advanced level now as it is, or maybe in senior class if you are in secondary school, that is high school. But then you still need to learn from that channel. Very important. Apart from that, your younger ones also need to learn. Yeah, if you go to that channel, to tell you the truth, I don't think any of your younger one has any problem, any reason to complain of whatever he or she is being taught from school. Many people will tell you they do not like math or whatever. The problem starts from basic level. Please, let me guide you and your younger ones. That channel is dedicated to primary 4, primary 5, primary 6, JSS 1, JSS 2, JSS 3. Yes, it's dedicated to them. I teach basic maths there. I teach basic English and generally English. In fact, GMAETS 41's English class is on that channel. I teach basic sciences there, and I teach quantitative there. All right. Okay, guys, we are done with this. Gabriel Ike, good morning. You're welcome to the class. You're welcome to the class. So how far have we gone in the class? What was the time? This is 1:41. Let's see if we could just hit it to 2 hours. Besides, you spend a lot of time in school. And let me tell you, for those in advanced level, if you're learning this in your lecture hall, it's not less than 2 hours because usually it's a 2-credit load course. So you can spend 2 hours and learn something wonderful from this channel. For dear friends in UNIZIK, University of Abuja, other universities who usually connect to this class, right? You see, by the time you are done learning this, if you return back to school during your second semester work and you are dealing with organic chemistry, the IUPAC nomenclature, you just be smiling. If your lecturer is on the board and then doing that, you'll be looking at it and smiling. You say, yeah, I think I know where he's going to or where she's going to. See how important what we are doing here is. I'm going to wipe this part of the board now, please. You can screenshot, finish up, so I'll wipe it, and then we would move on to acid amide. I think that will likely be the last homologue I would like to deal with today. I'm adjusting the camera now to capture the other side of the board. Right. Okay, so finish up, screenshot to be best for you. Then let us look at the next functional group of interest that should give attention to. We'll be dealing with acid amide this time around. Acid amide. That's the next one I am going to deal with. Acid amide. And we're almost rounding off with the IUPAC nomenclature. Remember, I've told you on this channel, you have the IUPAC nomenclature of alkanes, alkene, alkyne, alkanol, alkanal, alkanone. That's 6 homologues. Those functional groups have been treated. But it's not a live class. Go to the GMAETS 41's playlist, the videos on this channel, this particular channel. All right, I've already arranged these things for you guys so that you don't find it difficult making use of this channel. You are the one holding yourself back in learning now, and as long as GMAETS 41 is concerned. So you go to the playlist, search for Chem 102. That Chem 102 is specially organic chemistry only. Chem 101 deals with the concept of inorganic chemistry, okay? Chem 102 is organic chemistry specifically. If you go to that playlist, click on the playlist, the video lessons available there will pop up, the menu will pop up, then you scroll. You'll see IUPAC nomenclature of the first 6 homologues, which I mentioned: alkane, alkene, alkyne, alkanol, alkanal, and alkanone. And remember, in this live class, we picked from alkanoic acid. We've treated alkanoics, that is esters. I've just finished acid chloride. And of course, we'll be looking at acid amide. Looking at acid amide. So as we used to do it, first, you need to know the functional group of acid amide. The functional group of acid amide is ONH2. That's the functional group, CONH2. Acid amide. Acid amide. It is another derivative of alkanoic acid. That's the third derivative of alkanoic acid. The functional group is CONH2. So once you say this, you know that you are dealing with acid amide. Acid amide. And this guy is the terminal functional group, like I've listed for you already. Now let us talk about the pattern of the parent name. You can decide to expand this. If you expand it, it is C, double bond to oxygen, then downward NH2. So you can see how you obtain it from alkanoic acid. Alkanoic acid is this. Alkanoic acid is this. If you expand, you are going to get C, then double bond to O, and then OH. So like this one now, this is CONH2. So it's as if you removed OH and fixed the amino group. Are you following, right? If you expand it, you're going to get something like this. So usually this part of the alkanoic acid will be removed, the OH, and then replaced with a group of atoms. That gives you the derivative of alkanoic acid, as I said. All right, so let's move on, guys. Let's move on. No time. Acid amide, we've got this. And the parent name, like I said, pattern of parent name. Pattern of parent name. See, there is no way these stuff will be presented in this format. There is no way you will learn this stuff in this format and then you still have problems with IUPAC nomenclature. Get to know the functional groups first. Get to know the names of attachment, substituent. Get to know certain basic rules, how to determine the longest chain and other things, which I've been dealing with, you know. And then get to know the pattern in which the parent name is being given. Get to know the pattern in which the parent name is being given. Once you know all these things, your problem is solved. Now, the parent name. Should I go to the parent name fully now? Should I talk about the classification of acid amide first? Because depending on the classification of acid amide, there is a certain format in which the parent name goes. So I think what I will do to help you, because what GMAETS 41 does is to give students the best. Are you following, right? So let's look at classification first. Classification of this acid amide. Now we have primary acid amide, primary acid amide. I think we also have secondary acid amide. We have secondary acid amide, secondary acid amide. Are you following? And the primary acid amide is your normal. But let me write the functional group of primary acid amide. Primary acid amide is CONH2. Okay, then secondary acid amide. Let's see, I think that will be CONH, then R. Secondary acid amide, you have in the NH2, one hydrogen has been replaced with an alkyl group with chains of carbon. Then I think we've got tertiary acid amide. For that guy, we have something like this, and then of course there is no hydrogen anymore. No hydrogen on that nitrogen there. No hydrogen on that nitrogen. All the hydrogens on the nitrogen has been replaced with chains of carbon atoms, alkyls. They have been replaced with alkyls. Is that okay? They've been replaced with alkyls. So that is it. Now you know the classifications of acid amide. We can now talk about the way you give the parent name. Pattern of parent name. Pattern of parent name. Now, for the first one, which is this, primary acid amide. The parent name is simply alkanamide. alkanamide, 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 anamide, anamide. Okay, anamide. If the carbon skeleton between the carbon atoms, everything is single bond. If you have double bond within the structure like you saw under alkanoic acid, it will now become something enamide. That something is the position of the carbon atom bearing the double bond. Okay, but let's just focus on the anamide first. If I see any structure with double bond, of course, I'll deal with that. So alkanamide, which means, okay, for the first carbon atom, it is methanamide. Second carbon atom, ethanamide. Join me from there. Join me because I want us to take it to number 10. Third carbon atom will be what? Propanamide. Fourth carbon, be saying it so I can hear you from there. Yeah. With my mind's ear, I can hear you. This time around, it's no longer mind's eye. I can hear you from there. So join in the song. Carbon number 1 for this acid amide primary is going to be what? Methanamide. Carbon number 2, ethanamide. Number 3, propanamide. Raise the volume. Butanamide. Fast. Pentanamide, hexanamide, heptanamide, octanamide, nonanamide, and decanamide. All right, good. So that's the way you name the parent, guys. Okay, the parent name, the pattern. Now for secondary, we have something like this. For secondary, it's something like this. So the parent name, right? The pattern is N-alkanamide. N-alkanamide. N-alkyl alkanamide. N-alkyl alkanamide. N-alkyl alkanamide. All right, N-alkyl alkanamide. What is the meaning of this N-alkyl? You are telling us now that on nitrogen, this N means nitrogen. You are telling us that on nitrogen, you have an alkyl attachment on it, an alkyl substituent, an alkyl that has replaced hydrogen. You can see that. N-alkyl, nitrogen alkyl. So you have to mention the name of the alkyl. If it is CH3 now, it's going to be N-methyl. I hope I'm breaking this for you guys, right? This is a channel to always be. It's a channel to always stay tuned to, right? Like one of the friends here rightly said, think this channel, to be honest, with all humility, because whatever I do, I give the honor, the glory, and the praise to our God and helper Jehovah, who is making this happen, right? But in all honesty and with total humility, I guess you guys should push this channel up, right? This channel should be tending towards the million now, like the guy rightly said. Am I not trying? Your maths, your physics, your chemistry, because these are the course 10 subjects. These are the course 10 subjects. In advanced level, we talk about something about 10. In O level, it is being applied to O level now, right? In other Western and developed world. Science, technology, engineering, and math. You know, math, physics, chemistry are the core. And then GMAT still goes further to say we can't leave our basic level of learning aside, because we understand that challenges that our senior students and advanced level students undergraduates face most times, to tell you the truth, they are traceable to basic level of learning. So of all this level, GMAT 41 is giving its best to ensure that we continue to assist you to understand the things you're doing in school. I think I deserve the best, right? Please continue to subscribe. Share the links to this channel. Let video lessons on this channel go viral. Encourage your friends and others. Let them join. Do you get that, right? So let's move on. Now, the third guy, that is tertiary acid amide. Tertiary acid amide. You see, there is no hydrogen on the nitrogen again. So it follows this pattern, and the pattern of naming the parent is NN. NN. I think you use comma to separate the NN. You use comma to separate the NN. Then NN and then hyphen. Alkyl, 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 alkyl. Someone may wonder, what is he saying? Alkyl, alkyl, alkanamide. Good. By the time these stores are being broken down and explain what they mean, you You give it any structure you did. So NN alkyl alkanamide. Take note. This alkyl, you're saying the essence of this alkyl is in a case where you have two different alkyls here. Two different what? Alkyls here. If it is the same alkyl, let us assume this is methyl CH3, methyl CH3. It will be NN dimethyl, then you alkanamide, you end with the name of the parent. But imagine that this is methyl, for example, and this one is ethyl, 2 carbon atoms, 1 carbon atom. It will be NN, then you follow alphabetization. Ethyl will be mentioned before methyl. It will be NN, ethyl, methyl, alkanamide. And don't forget, if in the parent chain you have a double bond somewhere, like I said, alk something, enamide. All right, NN alkyl alkanamide. So this is the pattern, and I think we are set for the IUPAC name now. All right, we are moving on. Angel, thank you very much for the commendation and the appreciation. All right. Ester, I am confused for the formula of alkane, please help. I can't help you on this live class. I can't. I've always told you guys, please. It's as if I'm the one begging. Am I supposed to be begging you guys? Let's just be honest. I care about you people. I want the best for you. I know the challenges many students are facing, not only in Nigeria, because we live in a world now that many people, you know, I don't know the way they are saying the educational world. But for connecting to this class, kudos first, right? Kudos. However, follow my instruction. Follow my instruction. If you have problems with alkane, and whatever, as you said, ether, as in F4R, you can help yourself from this channel because the video lessons are available already. And let me tell you one thing. I want to challenge you guys. Like I said, it's not about pride, with total humility. At least in all of my video lessons, it is obvious. You guys should know very well that GMAT 41, total humility to the power behind what I am doing. Yeah, it comes from our God and helper Jehovah. It's not just about me. Am I communicating? Now, the video lessons of these stuff are available for you already. All you just have to do is take them. And let me tell you, my channel and my pattern of teaching is not something that, which is what I said I want to challenge you guys on. If I teach you, I mustn't be with you physically to teach you. I mustn't. My online works are such that when you are done taking the lessons, I put it to you, you won't have up to 5% of questions to ask. You won't. You won't. Guys, take note of something. GMAT 41 operating online now. I'm not here to talk about, okay, make YouTube videos, a content creator, okay, you come and join, my channel get monetized, and this and that. That's not my reason. My reason goes beyond that. If you watch my video lessons, you see the effort that goes into it. You will see the knowledge. You will see the commitment. You will see the desire to help students, to ensure that even though you don't see me physically, you learn and learn very well, even more than whatever you learn from your physical class. Right? That's the truth. So you want to be confident in taking video lessons on the GMAT 41's platform. If you take any of the lessons, you won't have up to 5% question to ask, if at all you even have a question. You know why? Whenever I am ready to deliver a lesson, a class, a lecture, I always put myself in the position of the student. If I'm the one learning this, what challenge would I likely have here? What problem would I have? What questions would I likely ask? And then these things, I put them in the teaching process so that even you, the question you might have while I am teaching, I've already covered it, because I know that at the instant of time, you may not be able to ask questions since you can't talk for me to hear you from there, except if I decide to bring you on live. Soon I'll be doing that when I decide to bring somebody on live. But you can only bring one person on live at a time, right? You can only bring one person on live, which means all that I just be watching what is happening. Like I said, I have stuffs. All right, I heard to do for you guys. So sometimes I might bring somebody on live. That is when you can talk, for me to hear you, for others to hear you. But right now, you can only type. And so because of that, I try to consider challenges you may have. So be confident in watching video lessons on this platform, and you would understand them all. Is that okay? You will understand them all. Chukwujuku George, thank you very much for commending me rather. God bless you all right? God bless you all. Please let us move on. Let's round off with this. In the next IUPAC nomenclature class, we'll finish with acid anhydride, which is another derivative of alkanoic acid. Then I'll move you to amines. Amines, you want to pronounce it amides. The choice is yours. We have things like methylamine, ethylamine, and then depending on the way the structure is being given, the amine, NH2, can be called an amino attachment. Don't worry, we're going to treat that in next IUPAC nomenclature class. Then after that, we'll deal with nitrides. Nitrides, where the parent name pattern is alkanonitride. And with that, we are done with IUPAC nomenclature at this level. I'll now be looking ahead to deal with IUPAC nomenclatures of the concept. That one is done by much more advanced level, 200-300 level. Okay, I think that is cyclic compounds, right? So let's get our first structure. Let's get our first structure. The first structure we have here an acid anhydride, acid amide rather. The first structure I have here an acid amide. Okay, let me see. Can I be able to squeeze that on this side of the board? I think I've got to adjust. I'll adjust the camera, okay? I'll adjust the camera. I'll adjust the camera. So let's look at some structure so we can round up. We've spent some good time. So the first structure I have here, number one, I've got this for you. CH3, CH2, CH, then we have CH3, then this. Good. Remember that this functional group is a terminal functional group, therefore the carbon of the ONH2 is number 1 always, number 2, number 3, and then number 4. Okay. Then on the second carbon atom, you have the substituent. Therefore, this is 2-methyl, 2-methyl. 4 carbon atom is but as prefix. As an acid amide, if you look at this is primary acid amide because all the hydrogen atom on the nitrogen are complete. There is no alkyl attached to this nitrogen, so it is primary. I told you it's alkanamide. 4 carbon atom will be butanamide. Butanamide. Good. That is it. I'm going to be a bit fast because you've understood all these concepts. That's my belief. And the belief is confirmed. Now, I've got this question. This particular question is extracted from Nnamdi Azikiwe University Organic Chemistry question. Unizik Organic Chemistry. And like I said, those of you connecting to this class from various schools and from various parts of the world, you want certain analysis, you can always send your question across, which is why I have advised you guys, become a channel member, send a message to this number, right? And request to be added to our WhatsApp group. You can send your questions across and I'll analyze them for you. But become a channel member, very important. Now I've got this structure, CH2, double bond, CH, then CH, we've got C, H, then OH, and then we have CH3 like this, then CH2. I think I'll have to wipe and still adjust this backward. Let me see the space. All right, can go backward a bit. So number 2. So we have CH2, double bond, CH. Then we have CH here, comes down. Have something like this. We've got CH2, C, then CONH2, CH2, and then CH3. So first of all, the functional group, look at it. So that guy is always carbon number 1. Attached to it is carbon number 2. So you check whether you have to go this way or go this way or go this way, the longest carbon chain. Clearly, you can't go this way. This will be 1, 2, 3, 4. Very short. 1, 2, 3, 4. You can come down this way if you want. 5, 6. However, take note. For this particular structure, you can't go this way. It's not done. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So you see, in this direction, you have 6 carbon atoms. In this direction, you have 6 carbon atoms. The question now is, which one will you take? That is a must. You must go in that direction. It's a must. You go in this direction. Reason, because of this double bond. So the parent chain, which is the longest chain, must contain all reactive functional groups. That is why you have to go in this direction. Remember, this OH, alkanoic functional group, can be taken as an attachment. You know that. Not that it can be taken. It is an attachment in this case. The double bond exists as a sub-attachment in the parent name. That is why you must count to include the double bond. So this is 3, this is 4, this is 5, and this is what? 6. Therefore, this becomes an attachment, this becomes an attachment. And looking at this, you should know the nature of the attachment you have here. This is substituent on a substituent. Because this carbon is directly attached to number 1. On this side, you have a branch. On this side, you have a branch. So you come over here, this is 1, 2, and this becomes an attachment because you can't count in this direction. This is not carbon. This is purely an attachment on this ethyl. Then this is ethyl attachment. Okay, so let's see how we name this guy. First, we have this attachment ethyl. This attachment here is 1-hydroxyl ethyl. On the first carbon atom of this ethyl attachment, you have 1-hydroxyl attachment. So this is 1-hydroxyl ethyl. And this guy is ethyl attachment. If I give you dictionary now and I say search for ethyl and search for hydroxyl, which one will you meet first? You will meet ethyl first. You see, I am always linking this to dictionary alphabetization order because you should understand that the fact that I named this guy first in the attachment is not because this one appeared on carbon number 2 before. No. It is alphabetization that I use. Assuming this whole guy was on carbon number 2 here, and then this ethyl is on carbon number 4, I would have to mention this ethyl on carbon number 4 first, before mentioning this hydroxyl ethyl on carbon number 2. You follow alphabetization rule whenever you are mentioning the attachment. So here, in this case of hydroxyl ethyl, hydroxyl and ethyl, ethyl will come first. So this is going to be on the second carbon atom, you have an ethyl attachment. Then on the fourth carbon atom of the parent, you have substituent on substituent. To the fourth carbon atom, you have this ethyl attachment. This ethyl attachment on carbon number 1, you have hydroxyl. So it is attachment on an attachment. Open the parenthesis. That's going to be 1-hydroxyl. 1-hydroxyl ethyl. So ethyl here as an attachment gave birth to another attachment, hydroxyl. And close it in bracket. There is no other attachment, so you go to the parent name. The parent name, 6 carbon atom, prefix is hex. You have to break it, hex something, and then you conclude. Why are you breaking? Because of this double bond. So it's going to be hex hyphen. On the 5th carbon atom, you have that double bond. We are dealing with the acid amide, and you can see double bond there. So it will no longer be anamide, rather it's going to be enamide. So 5-enamide. 2-ethyl for 1-hydroxyl ethyl hex 5-enamide. That is the name of that structure. That is the name of that structure. So we are done with that particular guy. We are done with it. So let's see if we can pick. We've been dealing with structures. I think these 2 structures are on primary amide. They're on primary amide. Let's do a round off. The weather is getting a bit dark. So I've got this structure now for us to look at. This is number 3. Structure number 3. I have CH3, then CH2, CO, NH, CH3. So you notice something now. Look at that functional group part. Look at that functional group part, CO, instead of NH2, as you have here. CONH2. You can see CONH, only one H. Then on that nitrogen, you have this alkyl group, which is methyl. Therefore, this is a secondary acidamide. Secondary acidamide. So, counting once again, we start from here. 1, 2, and 3. So, you have to start with this N something. Look at the pattern. N-alkyl alkanamide. So, N, what is the alkyl attached to this N, to this nitrogen? The name is what? Methyl. So, that is N-methyl. Then you conclude with the parent name. 3 carbon atoms. Prefix. Prop. There is no double bond. Everything is single bond. So, it goes with alkanamide. So, that's going to be propanamide. That's the name of this structure. Finish up. You can screenshot so that I will wipe the board and we'll take the last structure for today's class. The time for my basic class is approaching. It's supposed to start by 12 o'clock. This is 11:48 Nigerian time. This is 11:48 Nigerian time, so round off. I'm going to wipe this now. I'm wiping. I wipe here. I will adjust the camera. This part of the board, we just simply treated classifications of acidamide and the pattern of their parent's name. That's what we did on the right-hand side. For our great Zikite student, remember you are resuming soon. And I have activated, because this class, being that I operate with Unizik physically, because I'm here in Awka, Anambra State, and I run physical tutorials there. What holds you back from identifying with the GMAETS 41's physical tutorials, right? Registration is on. You can contact GMAETS 41 and register. Our classes are on already. Like, I think that was on Tuesday or so, we had Math 102, the concept of functions, right? Relations and functions. Perhaps you missed that class. Of course, this is meant for members only. Become a channel member. Now that you're on break, you can start preparing. You experience 100 level already. Nobody should tell you. Nobody should tell you. That's why sometimes I said, I think our problem is we ourselves. Somebody will face a challenge at one time and then still wait again for that challenge to still come up before preparing or planning to knowing how to handle it. I'm here, you're not paying anything yet. Just for you to become a channel member on platinum level, diamond level, you want to support us more depending on what is convenient for you. Right? So why not queue up with the classes? But all said and done, whether you queue up with the class or not, if you want to join in physical tutorial in Unizik, remember that GMAETS 41 is right there to give you the best of the very best. And you can just ask yourself this question. If this guy can hit this stuff so hard online like this, what will it be like if I attend this guy's physical tutorial? Right? You can only be imagining it. So it is not all about somebody coming to tell you maybe one lecture or whatever, this and that, go to. It's not about that. Remember, someone can advertise something that is not okay. Yeah, telling you. See, not in this world where everybody is looking for where to. So you can make that decision yourself. You are seeing it for yourself. Where to be. GMAETS 41 will be kicking off his physical tutorials in Unizik campus on the 5th day of May 2025. That's next month on the 5th, first week. Because I think you guys are resuming. I think you guys are resuming on the 28th of this April. All right. So start sharing this information. Tell your friends about this. And like I said, first class, that's the goal. First class, that's the goal. There is no set in Unizik that the GMAETS 41 student don't blast first class. This particular set, whose convocation was just conducted, I think last 2 weeks or so, people that were coached on this platform, they made wonderful results. At least there were 3 full first classes. Is it 3 or 4? Right? The second overall best in Unizik from civil engineering. was a wonderful guy on GMAT 41. 2020, when he joined this platform, until his 300 level. You see, and many more. The wonderful lady, Chiamaka. I respect you guys, and that's good. You see, this is what GMAT 41 stands for. That is what GMAT 41 stands for. And you can get the best. Contact GMAT 41 and join our tutorials, whether online or physical. Okay, I am adjusting this so that we take the next structure. I'm adjusting this so I will take the next structure. Like I said, this advanced form of structures, those going for JAMB, those going for WAEC, all these O-level exams, at least in Nigeria, I know you're not exposed to them. But the fact is, for you to be able to learn and understand all these advanced form of structures, then the ones you meet in your JAMB and WAEC, they'll be moi case, yeah, 1 + 1. And that's the truth. Because structures they give you in WAEC and JAMB, they are very simple structures. Those you can meet under alkane, alkanols, and the rest of that alkynes. Now, I have this last structure, number 4, that we are going to deal with today as we close the class, CH3. Now, let's say this is CH rather. Then I want to make it a bit complex. CH, then I've got this, CH3. And so I'm going to link this to CH2. Then CH2, CH2, then CON. We have CH3. I hope it has not cut off from view. And we have C2H5. But let me expand this. CH2 and then CH3. But it was actually written as C2H5. Let me see. Okay, I think let's look at this. Perhaps let me put an attachment here. Maybe to put an attachment is my choice. Can give you anything I want. Which attachment will I put here? Let me say I put bromine attachment. Permit me to put another attachment here. I can be funny sometimes, Let me put N there. Permit me to put another attachment here. Permit me to put another attachment here. Let me put NH2 because I want to tell you something about NH2 as an attachment, okay? I'm going to put that as an attachment. Let's round off. Okay, so we are moving on. Let me check that this has not cut off. Oh no, it's almost cut off. So let me adjust. Thank you, OBDK, for letting me know it's cut off. So I think I've gotten it. So. Fine. Counting we start from here, whether we like it or not. CON and then whatever NH2 is the terminal functional group. So this is carbon number 1. But if you look at this, the nitrogen that's supposed to be NH2 does not have any hydrogen on it again. Alkyls. This is methyl, this is ethyl. So I know you should be thinking of tertiary alkanamide now. Then let's see what we've got. Okay, I've treated the enamide something, so no need of removing anything and putting double bond. I wanted to remove a single bond somewhere and put double bond, but let's leave it. I've already treated the way you handle a structure that has double bond. So we have this as 1, 2, 3, 4, then 5. Now 5. I want to ask you this question. Look at this number 5. Look at this carbon number 5. If you notice on top you have CH3, under you have CH3. Does it mean that these two CH3s are substituent? The answer is simply no. Take note of that. Since you have this guy and this carbon number 5 is the last carbon along the straight chain. Is the last carbon along what? The straight chain. If you have CH3, that CH3 is a continuation of the chain. If you have this CH3, it is still continuation of the chain. So this is what happens. One of them will be taken as a continuation, the other will be taken as what? A substituent or attachment. So the choice is yours. Either you go 5, 6, this becomes a substituent. Or you go 5, 6, this becomes a substituent. Mind you, this CH3 you are seeing here could have been written backward like this. So that you have 5 and what? 6. And this becomes an attachment. Or this guy you are seeing here could have been brought this way. 5, 6. And then this becomes what? An attachment. So what is the point? A carbon attached to the last carbon of a straight chain, when you are counting longest chain, that carbon is not an attachment, but a continuation of the chain. It's really a bit dark now. Okay. I don't have the means of getting petrol today. Don't mind me. Let's round off, please. So I am going to take this to be a continuation of the chain 6. So I'm taking this as an attachment, this attachment, this attachment, this attachment. Then coming here, you know your NN something. Let's start with that, okay? Let's start with that before we look at this part. Coming over here, on the nitrogen, you have 2 alkyls. So that's going to be N, N hyphen. If this were to be ethyl, it could have been diethyl. Or if this were to be methyl, this could have been dimethyl. But if you look at these 2 groups, they are different. This is methyl, this is ethyl. So you follow alphabetical order. Ethyl comes first before methyl in dictionary order. And so that's going to be NN-ethyl methyl. What this means is that on the nitrogen atom there, you have ethyl attachment. On that same nitrogen, you have methyl attachment. Now let us go to the parent name. But before the parent name, notice that you have attachments. You have attachment. What is the name of this attachment? NH2 as an attachment is called amino. It's called amino. This one is bromo. This guy is iodo. You know, iodine. And of course, you know, this is methyl as usual. Methyl. That's methyl as usual. And that's it. So follow alphabetical order to know the attachment to mention first. So on the second carbon atom, this attachment A will come first. That is 2-amino. 2-amino. But the way I place this is as if maybe I'm following the way that these things are. Please, oh my gosh, I would have brought this amino here. So that you find out that in naming or in mentioning the attachment, it is not about the first attachment you see. No. I wanted to take this one here, bring this one here. Okay. But anyway, it doesn't matter. Let me just say it. Assuming this amino was here and this iodo was here, the amino is the first guy that I will mention because amino starts with A. It's going to be 4-amino. Are you getting me right? 4-amino, and then you follow alphabetical order. But the way this thing is, I don't know. Unfortunately, I've just written this and I just formulated the structure just now. And so I have to follow it. So 2-amino. Then you have bromine, you have iodine, you have methyl. This thing, somebody might look at it and think I was just following the positions of these guys. I will change it. Shouldn't I write Amadi? I hope I'm the one that wrote it. I will change it. I will change it. Let me reorder it. I'm sorry about this. You see why I said I always put you. I have you at heart whenever I'm teaching. If I had this written down before, I could have considered it, but I just formulated this. Let me bring iodine here. That is iodo. And then bring amino. So that somebody will know whenever you are having this class that you follow alphabetization. This is iodo. Alphabetical order, dictionary order. This is amino. Good. So it means this will be 4-amino. Anyone who is taking this will not be aware. It's not just about their position that you follow up with the attachment name, but about alphabetization. Amino will come first, hyphen. After amino, you have B. So bromo will follow, which is 3-bromo. Then after that, you have I and N. I will come, and that I is on the second carbon atom. 2-iodo. The next attachment is seen on the 5th carbon atom, 5-methyl. I think I'm done with all the attachments. Amino, bromo, iodo, methyl. That's it. So the longest carbon chain is what? 6 carbon atom. That 6 carbon atom is hex. Now there is no double bond between the carbon skeleton. Everything is single bond. So it is alkanamide. Hexanamide. That's the name of this structure. NN-ethyl methyl 4-amino 3-bromo 2-iodo 5-methyl hexanamide. This is cool. And of course, this is how we come to the end of our class today. So please, do you have video on isomerism? Yeah, I've done a little thing about that, but I think I'm still going to release a special video on isomerism. We'll focus on isomerism alone. I have done something, but not on isomerism as a topic. But let's say before next week is over, I'm going to release a special video on isomerism. It won't be live class. Take notes. It's going to be a pre-recorded video where you go to the playlist and search it in the chemistry playlist. All right, guys, thank you for tuning on to the class. It's already 12, and the class for the primary school pupils, primary and junior secondary school, that is basic 4 to 9. It's time for them to have the class now. So I am going to be leaving. Thank you for tuning on to the class. Always stay tuned. If you have not subscribed, subscribe and turn on the notification bell so that whenever I hit on any class, you know, if I am online or on live or upload any video, you will be personally notified. Share these video links to your friend. Encourage them to subscribe to and follow up with our classes. And don't forget, as I'm getting ready, at least, I know I'm going to delay a little. There about 12:30, I will start the basic channel class, right? I'll start the basic channel class. And remember, I told you the name of the channel is GMAETS 41 Basic Class. GMAETS 41 Basic Class. So if you want to connect to that class, basic maths, you're going to deal with basic board maths, you know, the order of solving question. And you guys in advanced level or in senior secondary, as the case might be, you need it also. Very important, because you need to know how to order your mathematical works. See you in our next class. Today is Thursday, guys. Our next class is going to be tomorrow. But tonight I'll be holding a class on preparations and properties of alkanols for those preparing for JAM and WAEC. That's going to be around 9 p.m. tonight, so you can still connect. Do have a wonderful day.